We're on topic 4, and we're going to do the exercises on page 13. And the problems we will do will be 1G, 1P, and 1S. So let's start with 1G here. And what we're asked to do is find the values of x that make 10x less than or equal to 11x minus 3 true. So what values of x make this inequality true? So we're going to use the same kind of rules that we used for equalities for inequalities. First, we're going to write down the equation. We write it. And we're going to make sure that the variable is on the left side of the inequality and the numbers are on the right. So we're transposing the 11x from the right to the left here. So we now have variable on the left, numbers on the right. When we subtract 11x from 10x, we get minus x less than or equal to minus 3. So the only thing we've transposed is the 11x term. Now we don't want minus x, we want x. So we want plus x. So we're going to multiply both the left and the right side by minus 1. And when we do that, the direction of the inequality changes. So less than or equal becomes greater than or equal right here. So minus x times minus 1 becomes x. Minus 3 by minus 1 becomes plus 3. And there's the change in the direction of the inequality. So the solution graph, since the solution is x greater than or equal to 3, so here is the 3. We're including that, the equal sign. And this bold line here represents the numbers that are part of the solution. So this arrow indicates that it's going out towards infinity, which is undefined. And because we're including the number 3, the equal sign right here, we put a square bracket around 3 in the solution set. So we can show the solution to this in terms of a solution graph right here. So here's all the numbers, including the 3, which would make the inequality true. And the other way we can represent this is to show the lower part of the solution, the number equal to 3, like that, put a comma, and then infinity representing the higher end right here. And because infinity is undefined, we're going to put a rounded bracket. Now, although it's not a foolproof method, we can check values or check the answer by using values that fall either in the boundary, within the solution set, or without. So we'll start by using x equal to 3, which is a boundary value, meaning that it's right at the end, because x could be less than or equal to 3. So we're going to put this back into the original equation, x equals 3, got the left side here, equals 10x. So 10 times 3 is 30, right here. And now we're going to look at the right side, which is this part of the equation right here. We're going to substitute x equals 3. So 11 times 3 is 33, minus the 3 is 30. And then we then ask ourselves, by putting the number, replacing the 10x here, and replacing the number that appears here for this when x is 3, is that true? So both the left side and the right side are 30, so we say that is 30 less than or equal to 30. 30 is equal to 30, so it is true. So x equals 3 lies within the solution set. Okay, we're going to use a number in a second check. None of these are obligatory, but they help us confirm what we found as the answer. So we're going to use a number that lies in the solution set, but which is greater than 3. So one of the easiest numbers to choose would be 4. It's right about here. It lies within the solution set, and go through the same thing that we did last time. In other words, put x equal to 4 right here, x equal to 4 right here, and ask ourselves whether this inequality still holds true. So we take the left side, and we've got 10x. 10 times 4 is 40. We take the right side, right here, 11x minus 3. Substitute the x equals 4. We get 11 times 4, which is 44. Minus 3 is 41. So what we found is that this side, when we replace the x with the 4, is 40. And when we replace the x with the 4 on the right side, we get 41. So we ask ourselves, is 40 less than or equal to 41? And the answer is yes, 40 is less than 41. So x equals 4 lies in the solution set. So we've chosen two numbers that lie within the solution set. Let's use a number that does not lie within the solution set to verify that we've got the right answer. For example, we know that x equals 2. If we go up here and we look over here, you can see that 2 lies within the solution set right here. So let's try 2 and substitute it into both the left side. 10 times 2 is 20. The right side is 11x minus 3. 11 times 2 is 22. Minus 3 is 19. And then we substitute into the left side, right side, getting these answers, and ask ourselves, is 20 less than or equal to 19? No, 20 is greater than 19. So x equal to does not lie in the solution set. So what we did here, what we've done on this page, is to find that the solution set was x greater than or equal to 3. So we tried the number 3, we tried the number 4, and the inequality held true. We chose a number, then chose a number with outside of the solution set at 2, and this inequality is no longer true. So this is a way of verifying our answer. As I said, it's not necessarily foolproof, but it does work. Okay, so now we're going to number 1p. We look at this equation, and what are we asked for here? We're asked for the values of x that make this inequality true. So we have this inequality, and we want to know the values of x that make that inequality true. First thing we're going to do is remove this set of brackets, this set of brackets, and this set of brackets. We're going to use the distributive rule and get rid of the brackets. So plus 7 times plus 5x gives us 35x. Plus 7 times minus 2 gives us minus 14. Minus 9 plus 3x gives us minus 27x. And minus 9 times plus 1 gives us minus 9 on the left side. Now we go to the right side. Plus 5 times 3 plus 3x gives us 15x. Plus 5 times minus 8 gives us minus 40. And we have minus 4 because of this term here. So we now got rid of the brackets using the distributive rule. Now you can see here that the object now is to get the variable terms only on the left and the numbers on the right. So minus 14 and minus 9 are on the left side and should be on the right. So we change that to plus 14 and plus 9. We transpose the minus 14 and the minus 9 from the left to the right side, right here, and change the sign. Now, similarly, if we look at this side, the 15x should be on the left side. So we're going to move it from the left to the right and change the sign. Here it's plus 15x. On the right, we make it minus 15x on the left. So now we have all the variable terms on the left and all the numbers on the right. Now, one thing we can do to make sure that we've done this correctly is to look at the number of terms on this line and compare it to the number of terms on this one. Make sure we haven't dropped the line. So we have 35x. We have 1 term, 2 terms, 3 terms, 4 terms, 5, 6, and 7. We count over here. We have 1, 2, 3, 4, 5, 6, 7. So that way we can be reasonably sure we haven't dropped a term in going from this line to that line. We take 35x minus 27x, we get 8x. 8x minus 15x gives us minus 7x. So combining these 3 terms together gives us minus 7x. Minus 40 and minus 4 plus 14 plus 9 gives us minus 21. Minus 40 and minus 4 gives us minus 36. Minus 44 plus 14 gives us minus 30. Minus 30 plus 9 gives us minus 21. So at this point, what we want to do is we don't want minus 7x here. We want only x here. So to go from here to here, we have to divide by minus 7. Well, if we divide the left by minus 7, we have to divide the right by minus 7. And when we divide by a negative number, we have to reverse the inequality. So the greater than sign here becomes less than over here. Minus 7x divided by minus 7 gives us x. Minus 21 divided by minus 7 gives us plus 3. So the solution to this inequality is x less than 3. We can write this as a solution graph or a solution set. Just as a reminder, what we're saying is x, if x is less than 3, this inequality will hold to be true. That's what we're doing. So the solution graph, here we have the 3. This should be bold down here. So really this represents the graphical solution of what the values are. The rounded bracket here means that we haven't included the 3. The solution set, here the negative end of this is minus infinity. And because that is undefinable, we put a round bracket here. This end here, 3, is shown with a 3, and the rounded bracket here indicates that the 3 is not included. So any number that's greater than 3 could be, any number that's less than 3. Sorry, any number that's less than 3 would be a solution to this. So from here on down would be the solution set, not including the number 3. So let's use a number that lies within the solution set. If you look at the solution set, we could choose the number 0. Because the solution set is from here on down, we can check that we have the right answer by testing with the number 0. So we're going to put this back into the left side of the equation, which is right here. Here's the left side of the equation. And we're going to replace each of the terms with x in it, this one and this one with 0. And 5 times 0 is 0, and 3 times 0 0. That's why 0 is sometimes an easier number to work with and makes the calculation easier. So replacing the x with a 0 is minus 2 in the bracket. Replacing the 0 here, 3 times 0 is 0, leaves us with 1 in the bracket. So we have 7 times minus 2, which is minus 14. Minus 9 times plus 1 is minus 9. Minus 14 and minus 9 is minus 23. And if we go to the right side, which is this term over here, and we've rewritten it here, we replace with the x with a 0. 3 times 0 is 0. We've got 5 times minus 8 minus 4. 5 times minus 8 is minus 40. Minus 40 minus 4 is minus 44. So now we look at this equality here, and we look at what we found on the left side, minus 23, right here. We look at what we've got on the right side and ask, is minus 23 greater than minus 40? Minus 44, and the answer is yes. Minus 23 lies to the right of minus 44 on the number line. It's greater than, so x equals 0 as a test point works, which is what we would expect. Now let's choose a number that doesn't lie in the solution set. You can see the solution set is from 3 down, not including the 3. So we go over here on this side, then any number that we choose on this side, it doesn't have to be 4. We could choose 5, we could choose 6, we could choose 3.5. But we usually choose a number that's close. So here we'll put the number 4. You can see 4 does not lie in the solution set. We're going to substitute the number 4 into the left side, then compare it to what we put into the right side and ask ourselves, is that still greater than? So let's look at the left side, which we've rewritten here. 5 times 4 is 20. 3 times 4 is 12. The rest is arithmetic. 20 minus 2 is 18. 7 times 18 is 126. 12 plus 1 is 13. 9 minus 9 times 13 is minus 117. So we're left on the left side with x equal, or with the left side equal to 9 when x equals 4. What about the right side? This part right here, when we put x equal to 4. Well, 3 times 4 is 12. 12 minus 8 is 4. 5 times 4 is 20. 20 minus 4 is 16. So we've replaced the left side of the equation where x equals 4 and the right side of the equation where x equals 4, and we're left with 9 being the left side, 16 being the right side. Is 9 greater than 16? And the answer is no, 9's less than 16. So x cannot fall within the solution set. So first of all, what we've done here is we found the solution set, and we know that it's a number less than 3. We tested with a test number 0. We could have used 1 or 2 or minus 1, but we chose 0 because it's easier on the arithmetic, multiplication, etc. We tested with 0, and the inequality held true, which we did expect to be true. And then we chose a number outside x equals 4 and found that it didn't hold true, which is what we would expect. The next problem is we're solving for x, and what we want to know is, as in the other problem, what are the values of x that make the left side of this inequality less than or equal to the right side? You'll notice we have an x term here, and we have an x term over here. In other words, our variables on both sides. first thing we're going to do is remove the brackets here. Remove this set of brackets, use the distributive rule. 3 times x is 3x. 3 times minus 2 is minus 6. And then we still have the minus 1 less than or equal to 5x plus 7 over 4. So the only difference between this and this is we use the distributive rule to remove the brackets. Now, we have the number 4 here in the denominator here, and we don't like to have a fraction. It's easier if we work without a fraction. So what we're going to do is multiply the left side by 4, which we've done over here, and multiply the right side of this by 4. Remember, whatever we do to one side, we must do to the other side. So we multiplied the left side of the inequality by 4 and the right side by 4. So this 4 cancels with that 4. This is on the numerator, this is on the denominator. So the left side has been canceled here by, the 4 on the numerator is canceled with the 4 here, and we're left with 5x plus 7. So now we have a simpler equation than what we started with over here, but it's still not exactly in the form that we like, because the minus 28, the number, should be on the right side, and the 5x, which is on the right side, should be on the left side. So we transpose the minus 28 from the left to the right, make it plus 28, and transpose the 5x, which is on the right side here, to the left side and make it minus 5x. So we're just changing the side of this. So now we just have the variable on the left and the number on the right. 12x minus 5x is less than or equal to 7 plus 28. 12x minus 5x gives us 7x. 7 plus 28 gives us 35. So now we have the 7x less than or equal to 35. We divide this side by 7 and this side by 7. Because the number we're dividing by is positive, dividing this by 7 and this by 7, the direction of the inequality doesn't change. So the solution set is any number that's less than, if x is less than or equal to 5, then it is a solution for the original inequality. So the solution to this is, as long as x is less than or equal to 5, the left side of this equation will be less than or equal to 5x, to the right side. So here's the solution graph for this, x less than or equal to 5. So this is bold, and here we have, this is going towards negative infinity, so the boundary is shown like this, negative infinity, because you can't define infinity. We put a round bracket here. Because we have, including the number 5, we have the square bracket here, right here. Either of these represents solutions to the problem. So now as a check, let's choose numbers that lie within the solution set. And again, we're going to choose 0 because 0 is a number easy to work with. We go back to the left side of the equation, 3x minus 7. Put x equal to 0, and we get minus 7. Now we can go to the right side of the equation, which is 5x plus 7 over 4. Substitute 0, and we get 5 times 0 plus 7 over 4, which is 7 over 4. Now, I'm going to change this into something that maybe is a little better to understand. I'm going to divide the 4 into the 7, so I get 1 3/4. This makes us easier to compare the two numbers that we got from the left side to the right side. Now, instead of writing 7 over 4 You can write 7 over 4, just easier to understand. Now, the question is minus 7 less than or equal to 1 3/4? Well, the very fact that this is a positive number, whether we use 7 over 4 or 1 3/4, the fact that this is a positive number, minus 7, has to be less than any positive number. So the answer is yes, so 0 falls within the solution set. Now let's choose a number that doesn't fall in the solution set. For example, 6. We could use 7, 8. We could use 5.5. We could use 5 1/4. But we'll choose a number close. And we'll see left side 3 times 6, substituting x equals 6. 18 minus 7 is 11. Go to the right side and substitute x equals 6. 5 times 6 is 30. 30 plus 7 is 37 over 4. We divide 4 into 37, and I get 9 with a remainder of 1, so it's 9 1/4. So now we ask ourselves, substituting x equal 4 into this gives us 11. Substituting 4 into that gives us 9 1/4. Is 11 less than or equal to 9 1/4? No, 11 is greater than 9 1/4. So x equal to 6 does not fall within the solution set. So that completes page 13, and the next segment will